Welcome back to the show. Don't let the dog days of winter get you into a learning rut. We have one of our favorite people, one of my favorite people here, Mama Gone Geek, here to show us some science fun. From her books, Pop Bottle Science and Big Science for Little People, please welcome back to New Day, Lynn Brunelle. Thank you for being here.
Thank you for having me. I love coming to visit you.
Well, and I love taking what you teach me home to my kids and giving them that excitement for science. This is the only time they ever listen to me when I'm talking about science. If it's geology, they're off in another world. But when I take Auntie Lynn's science projects they love it. So let's
get started. Okay, so the first thing we're going to do is a little experiment called magic milk. So go ahead and this is whole milk.
Okay.
Put it in a little plate so you've got a little palette of it.
Okay.
And then you're going to take some food coloring and you're going to put like just a drop here and there, not a lot, and you can mix the colors. That's fun to do.
Okay.
I'm going to do
and it has to be whole milk, right?
Whole milk is good because you want the fats in it.
Okay.
And you'll see why in just a second.
All right.
You get Christmas. So here's your Q-tip and here's my Q-tip.
All right.
This is a fun experiment to do. You don't even have to tell the kids. You can do it as a magic thing. But you want to dip a little bit of dishwashing liquid in. Now, soap polarizes molecules. And because milk has got fat and water in it, it polarizes the molecules.
So
which
it
means
separates them.
It makes the grease flee off. It makes the water pull towards it.
And that's why it's effective in cleaning dishes, I see.
Watch this. Just put it right in the middle. See what happens.
Whoa!
Isn't that fun?
Oh my gosh! Look at that! Look at mine, Lynn. It's like a.
Oh, that is nice.
Because it went under the water,
right?
or
so
under
you
the
see
milk?
how it's pulling? It's pushing the color right to the edge because it's actually repelling some of the molecules.
And this is something we all have in our house.
Yep.
So I'm going to.
And it's why soap gets you clean.
And it's why soap gets you clean.
There we go. Magic milk.
Look at that.
And it's really fun to do this over and over again.
I really wish.
You can do all sorts of springboards with it. You can do color mixing, like I've done yellow and blue, and you can see the green happen. So if you wanted to do little combinations of that
is
kind of
fantastic.
thing.
Okay.
That's magic milk. Okay.
That is so fun. Magic milk. All right.
Another thing that God, when my kids were little, these things would be on the counter for months.
Oh.
We make homemade lava lamps. And so what you do is you just take a pop bottle, you've taken the label off. This is just regular tap water, and then I'm going to pour some oil. This is just cheap oil.
All right.
Pour it in.
Like kind of like 1-to-1 ratio?
Yeah, maybe like more oil to water.
More oil to water. Copy that. Okay.
Yeah, like, here's half. I mean, if actually, you know what? Let's try it with half and half.
All right.
Sorry, we'll just do this on the
that's
fly.
Science, right?
Yeah.
We're just trying to.
Sorry.
It's all good.
Wash your hands there. I got some soap.
You know
if you
what?
need it.
I can feel the things polarizing on my hands.
All right, I'm going to put a little bit more in. So I'm just going to fill this so it'll be good visually. Let's get rid of that.
All right.
Then pick a color that you like and go ahead and put it in.
Let's
the color you want your lava lamp to be.
I think red will be, okay, how many drops?
Why don't you do 5?
Is that
Perfect.
Good?
Yep, that's good. And so you'll see, because this is water soluble, it doesn't mix with the oil and it just sort of drips down and sits there.
Okay.
Now this is an Alka-Seltzer. And you know what happens when you put Alka-Seltzer with water?
Yes, I do.
It's a chemical reaction.
All right.
And go ahead, you're going to just drop the pieces in and see what happens.
Oh, I'm excited to see.
You drop it in.
Here we go. Alka-Seltzer to the rest.
I always like to do a lot.
Okay. Let's put it all in there, Lynn.
It's fun. And so you can see it's bubbling up. It's creating a chemical reaction. Carbon dioxide is coming up. It bubbles up, and because of that, it mixes the color back in. But the bubbles that go up are just gas that want to escape. As soon as they escape, the water sinks back down. And so you've got this up, down, up, down, up, down, and this will go on. And here's the thing: you don't ever want to cap it because it'll just. But you know, once the Alka-Seltzer kind of fizzles, throw another one in, and it's really fun to put a flashlight underneath it, and it just is constant. So I said we've had these going for months at a time at our kitchen counter.
All right, I love it. Okay, so next we've got, this one is super cute. I love this. There's a tiny little
leaping lizards.
Tiny little geckos she's cut out of tissue paper.
And you don't have to do lizards. I just kind of whip those out, but you can cut any shape that you want. Like say you want to do worms, you can do a couple of worms and throw them down too. But tissue paper is what you want.
Okay.
And this is a static electricity thing. So you're going to take this balloon, you're going to rub it on your hair.
Okay.
Okay.
And
then you're going to just sort of wave it over. You don't touch them, but they'll come up to you. Yeah.
They're leaping.
They're leaping. So what's happening?
Everything's leaping to me.
You loaded up electrons on this balloon, so negative, negative, and it's looking for something positive. And so what's happened is that the paper, the positive ions are on that side, and they're drawn to each other. So that's what you can do, and this is really fun to do. You can just, ooh,
all right,
make them dance. And
we only have about a minute left, but I want to talk about Brunelle's principle and then this fun thing. So what is this?
So, a big question that kids often ask is, how do airplanes stay in the air? And it's amazing because it works every single time. It's physics. Wings are shaped in such a way that the air moves faster over the top of the wing.
Okay.
Because it's moving faster, there's fewer molecules. So there's a teeter-totter imbalance, right? Fewer molecules are pushing less on the top of the wing than the molecules that aren't moving so fast. There's a lot of them, and they're pushing up on the wing.
So that creates lift.
Right. And so here's one cool thing. So go ahead and turn that on all the way to high.
Okay.
All right. Blow dryer, and you might think that that's just going to blow it away, but it'll stay right in there.
Look at that!
Whoops.
That is so cool, Lynn.
I know, isn't that? Yeah. So that is why airplanes stay in the air, and you can do the same thing. This is super fun to just blow your woo. If you want to.
Oh my gosh, Lynn, I love this. And then you can do your hair a little bit afterward. It's fabulous.
Yes, exactly.
Thank you so much. We appreciate it. You
Yeah,
always have the
thank you for
greatest
having me.
stuff, and thank you for educating the kids. We're going to have all this on our website and more. So go check that out if you want to do this with your kids as well. And if you do, take pictures, send them to us. Lynn and I would love to see.
I'd love to see that.
We would love to see. All right, here I am.